we're going to use Excel to satisfy the requirements of the data processing and presentation, in particular the processing of the data to be able to plot a graph, a relationship between two variables with the maximum and minimum lines of best fit and a variable uncertainty. We're going to produce a graph a bit like this. We have the maximum line of best fit, the minimum line of best fit, and we have the line of best fit, which is roughly somewhere in the middle between them, and each point has a variable random error, which is actually the sum of the random error and the instrument position uncertainty. Now we have to do roughly 7 steps. The first one is to, with the data, find the average of the values. Then we find the maximum and the minimum values for each set of trials, and from this we can find the range for each set of trials. Then we find the half range, which is basically the uncertainty for each set, and then we must find the total uncertainty, which is the random error plus the instrument position uncertainty. Then we need to generate a graph which shows we need to generate 2 other graphs. One shows the maximum line of best fit and one the minimum line of best fit, but we must generate the points that will give these lines. And then we plot the 3 lines showing the maximum minimum lines of best fit and the average line of best fit with a variable uncertainty. So here we have our set of data. In the experiment we basically changed the job height. We dropped an object different heights and we measured the time with a stopwatch, which is not very accurate way of doing it, but we measured it with a stopwatch, and we measured 4 trials for each height for the object to fall. Now the first step we need to do is to find the average of these. So we need a function for the average of the first 4 trials equals average, open brackets, then we want an average of these 4 here, close brackets. This gives us the average. And we want to do this to all these values, so we just take this and drag it down, and it does all these calculations by itself. Don't you just love Excel? Next we need to find the range, so we need to find out what is the minimum value and the maximum value. First of all, the maximum equals max, open brackets, of these 4, close brackets, and this is the maximum value, 0.28. Is that correct? Yes. Then we find the minimum value equals min, open brackets, of the first 4 trials for the first point, close brackets. Is this the minimum value, 0.15? Yes, this is correct. So this we need to drag down, and this we need to drag down. We need to find what is the range here. In other words, this is the third point, is to find the range, or rather half the range. The range is the difference between the maximum and the minimum values for the first data point, and then we halve it. So this is going to be equal to the difference, so it's equal to the maximum minus the minimum, close brackets, divided by 2, and this is half the range of the random error. Now we now want to find the total half range, which is basically the random error plus the instrument position uncertainty, which is 0.005 seconds. Now we need to find the total uncertainty, which is equal to half the range plus 0.005 which is 0.07, drag this down. So once we have this, the total uncertainty, this is going to be the size of the error bars, which is unique for each average, and then that can be plotted. But first, in this particular experiment, we're not really interested in the height against the time, but the height against t squared. Let's find what t squared is. Let's do it the easy way. T squared is equal to the average value for t times by the average value for t, which is basically t squared. And we're going to drag this down to find all the values for all the average values squared. But we want to find what is the uncertainty with this. Now this is the total uncertainty for t, not t squared, so we need to convert this into a percentage uncertainty. So what is the percentage uncertainty of 0.07 as a fraction, as a percentage of the average? So it's going to be equal to 100, because we're finding the percentage uncertainty, times by the total uncertainty divided by the average. So this is the percentage uncertainty, which is 0.07 is a percentage of 0.19. It's basically 37%. We'll drag this down. We need to convert these and be able to compare them to t squared. So we're basically going to find out if this is the percentage uncertainty of t, what is the percentage uncertainty of t squared? Well, when you square, it means you have to double the percentage uncertainty. So this is going to be 2 times by this cell. So we have 75% uncertainty in t squared. Then finally we need to convert that into an absolute uncertainty of t squared, 75% of t squared. So it's going to be equal to 75% times by t squared divided by 100 is equal to 0.0259, and drag that down here. So now we have all the values for t squared and the absolute uncertainty. Now we're going to tidy this up a little bit by taking the important points we need and put them in this table below. So let's take the t squared values, Control copy, Control V. Now if we notice, it's got this error, which is this wrong reference, because it's trying to make a calculation relative to this cell, or rather relative to this cell, but it's just the absolute values we want. We just want the values, so we just put the values here. And here again we want the absolute uncertainty of t squared. Control copy, Control V, and here again we want just the values. Okay, so we have the drop height against t squared, and we can produce the uncertainty for each value of t squared. Now we also need to plot the line of best fit, the maximum line of best fit and the minimum line of best fit. To draw the maximum line of best fit, which is basically the steeper line, we have to start with an underestimate of the smallest point and an overestimate of the highest point. So this is the smallest point. So this is going to be the value for t squared minus the uncertainty, and this is going to be an overestimate, so it's going to be the t squared plus the uncertainty. Then we have the minimum line. This is going to be an overestimate of the first point and an underestimate of the last point. So this is going to be equal to t squared plus the absolute uncertainty, and this is going to be equal to t squared minus the absolute uncertainty. Now we can basically plot this height against t squared, also another line which is the maximum line of best fit from the first and the last point, and the minimum line of best fit from the first to the last point. Okay, let's insert scatter graph, scatter, and here we have it. Notice this is the size of the final uncertainty, which is quite large, and this is the initial uncertainty, which is quite small, and we have to put the error bars there as well. Okay, let's put the error bars. So we go to Layout, Error Bars of the first series. Remember, more error bars options. We're looking at the first series. Okay. We're looking at the vertical error bars, not fixed value. We want to customize it because each value for t² is a different uncertainty. We have to specify the value, and we define the range. We'll do that here. This is the absolute uncertainty. So it shows the uncertainty which corresponds to each value of t². And that's the positive error. And now we do the negative error, which is going to be the same thing. So, okay. Close. I'm not interested in the horizontal error bars just now, so I'll delete that. So here we have the red line will be the maximum line of best fit, the green one will be the minimum line of best fit, and the blue one is actually our sort of points with these varying error bars. Now the last thing we need to do is just to write the equations of plot the lines of best fit, the straight line graphs, and then put the equation for each line. We don't need the legend. So let's make it a bit bigger so we can see what we're doing. So first of all, let's do the maximum line of best fit, add trend line, display equation on chart, and it's going to be linear. Close. So that's the maximum line of best fit. Then the minimum line of best fit, linear, display equation on chart, close. So put this one here, we place this one here, and then we find the average, which is basically the line of best fit for the points that we had. Right mouse click the middle one, add trend line, display equation on the chart, linear. And so you have it. So the blue one, the middle line, is the line of best fit, the red one is the maximum line of best fit, and the green one is the minimum line of best fit. And this is basically what you need to be able to do. Later, of course, you need to label the axes and put the unit. Remember, this is a measurement of time squared, so the unit will be seconds squared. This is a measurement of the drop height, which will be measured in meters. Then you need to discuss these points. How reliable are they? Whether the line of best fit actually goes through all the error bars, which it doesn't. So you need to discuss this. But this is how we use Excel to do this, to do a graph of this nature.